You're listening to Hawk Talk. I'm here today with Bob Lanker. How are you?
I'm good. How about yourself?
Good. Thanks for coming on. So to kick it off, I assume the day you're born, you start making comments on the equipment in the delivery room and ways you can improve what's going on in the hospital from day one, right? That's how it kicked off.
I don't think so. I wish I could say it, but I don't even remember what happened then.
Nice. So give me an idea, like first off, where are you from originally?
I'm from Albany, New York.
Nice. And
I grew up there. Yeah.
and what were your parents like? Like, were you born into an academic household, engineering household? What were their
Yeah. Not really. My dad, he was, he went to Union College, and then he actually did get a master's degree at Harvard in English, but
uh
he got out during the Depression, and there weren't any jobs for teaching English except maybe in North Dakota or something like that. And
uh
he didn't want to. He was grew up in New York State and wanted to stay there. But then he went into World War II, and he was in the Air Force for 4 years.
uh
When he came back, he ran a pool hall with a friend of his in Troy, New York. And then mostly he ran liquor. He owned a liquor store, small liquor store in Albany, New York.
Nice.
My mom was she was a stenographer. She,
Oh.
for a couple of years, and then basically took care of myself and my sister.
So growing up, what I'm curious because again, what leads to who you've become? What were your interests? Like, were you an athlete? Were you into sciences back then? Were you into engineering? Like, what were you doing as a kid? Where were you
Yeah.
gravitating towards?
Well, I'd say, I think I had a pretty normal childhood in the sense, I'd play sports like in the neighborhood. We'd play football or baseball, or we called monster ball or other kind of basketball. But I did, my dad and my grandfather would play like math games with me. And I think that got me, and I was pretty good at doing stuff in my head.
Uh-huh.
And then when I was, I don't know, maybe 9, 10, 11, I got these gifts, like what they had these sets, like Gilbert was a company, and they made like an erector set where you could make a robot or a merry-go-round
Yeah.
or a rocket launcher. And they had a microscope set, where you could watch, shrimp hatch. And they had a chemistry set, and I got those for like Christmas or birthday presents or stuff like that, Hanukkah
Uh-huh.
presents. And so I'd, so I did have that influence. And I enjoyed those sets.
Uh-huh. And was there something you remember, like when you were a kid? Was there like, when I grow up, I want to be X? Were there any talk like that?
Yeah, it's a good question. I don't think so.
Uh-huh.
Certainly nothing that really stays with me that I wanted to be anything in particular.
You're just kind of enjoying childhood.
Yeah, and my dad and mom were always good that way. They always would say, they just want me to be happy. I mean, it
Yeah.
wasn't like they were saying you have to get good grades or anything else like that.
Huh. Did you get good grades, by the way? Seeing where you ended up?
Well, I'd go back and forth. I got very good grades in math,
Uh-huh.
and but I had, and I'm sure I still do have what's called attention deficit disorder. I didn't know at the time what it was, but I had a hard time paying attention in like classes like English or French or history.
Yeah.
Math. Some of the math I could do in my head, so that was
Yeah.
easier. And so, but I'd say that I did. Some years I did extremely well. I never could figure it out. I mean, why I would do better sometimes than others. Like I say, I didn't know what attention deficit disorder was. It didn't
Yeah.
exist when I was, or in people's, you know, at least I didn't know about it, and I don't think my parents or teachers did.
Yeah. Got it. And so as you got closer, like through high school, like in high school, what were your interests? Were you more of the athlete side? Were you like really getting into science at that point? Like what was happening during your teenage years?
Yeah. So I was I did do sports. I was on the JV basketball team. But the thing I did the most, I suppose, was track. I ran the 100-yard dash and the 220, and I
Uh-huh.
was captain of the track team and my senior year, and I won their main award, I guess, gold award. But I don't want to say like I was a great athlete. I was a pretty fast runner
Uh-huh.
for Albany, New York, but certainly no Olympic champion. And in terms of science and other stuff, no, not more than what I said.
Yeah.
I had those sets, and I but I like, I think, I suppose, the way I look at high school, I like classes like science and math more than I like classes like English and
Yeah.
French.
Was it? Do you think it was have to do with like that there was a concrete answer and it was logic based, or like what do you think drew? Obviously, you had a talent for math, but why did you like that side of it versus again the arts side of it?
Well, first, I wasn't very good at the art side of it. Like
Yeah.
one of the things I remember, in English, like you'd have to, do poetry, which was nice, except they want you to interpret poems. And I was like terrible. I mean, I couldn't have a clue of what the symbolism meant. And so and it was sort of frustrating how bad I was.
Yeah.
And French, I don't think, I mean, a teacher was terrific, but I didn't. She used to say I spoke franglais or something. I mean, I suppose that articulates what the way I even said that, what she meant. So, I didn't like being so bad at these things, I guess,
Yep.
and that was frustrating to me too. Whereas math, I was good at, and science, I don't know that I was great at science, but I was not bad.
Yeah. No, I think you lean into the things that you're good at, and it's enjoyable to be good at something. So, and then you get
Well,
better at
yeah,
it.
and you feel. I think it gave me more confidence. When I
Yeah.
was dealing with things that I liked, and I
Yep.
did like math. I did like math, and
Yep.
I did like some of the chemistry things.
Yep. Makes sense. So you get ready to go to college. What did you go to college for?
Yeah, so that's a good question, and again, I'm lots of people have like this vision of what they're going to be when they grow up. Well, I
Yeah.
certainly didn't. But my dad and my guidance counselor said, well, if you're good in math and science, you should become an engineer. And I honestly did not know what an engineer was. I actually thought they ran railroad trains.
Yeah.
And I didn't know why math and science would make me good at that. But anyhow, everybody said, or those two important people said that was a good thing to do. So I went to college and I was going to major in engineering. So, yeah, so that's
And
what
where'd you end up going?
Cornell.
Okay. And so stuck to New York, go for engineering, thinking you're going to be a train conductor. Um, when you got there and you started taking those classes, what was it like? Was it like, oh, I found my thing, I'm glad I listened? Were you immediately enthralled in the subject?
And I wish I could say that was the case. That was really hard for me. I
Yeah.
think that the classes I took in high school didn't really prepare me for Cornell, and it was really hard for me my first year and a half. I didn't get great grades, maybe B minus or something like that.
Uh-huh.
And I really had a hard time with like physics and a number of different kinds of classes.
What do you think was difficult about it as someone that was, so good at it in high school and middle school and grew up with liking math?
Well, math would have probably been okay, but I don't know that I took much math.
Got it.
I think physics, the level was just so much harder. I mean, the questions were harder, um, and they had and things like that. And so it was just, and it wasn't like I was great. I was okay
Yeah.
in high school and some of those things, but I wasn't great at it. And it was just a whole level beyond what I did and had done. And I don't think that a lot of the other people who had taken these classes, I think, went to really good high schools. Not that mine was terrible, but they certainly had taken what's called AP or and things
Yeah.
like that. A lot of them did. So it was. So I don't know, and when I look back, that I was that surprised, and also that I didn't do great. Also, the other thing, going back to that ADD thing, is they'd have lectures, and
Yeah.
I couldn't. I'd fall asleep in every lecture. I just couldn't pay attention. There's 300 or 400 people in the lecture, and I thought, geez, I just had trouble understanding stuff.
Yeah. And you mentioned it was like the first year and a half. Did something switch after a year and a half at school?
Yeah, yeah. So I don't know that I've ever really said this much publicly, but what I did is, I thought to myself after the third term, when I was not doing very well, if I keep falling asleep in class, I know a lot more comfortable place to sleep, which was my bed.
Yeah.
And so I didn't go to any of the lecture classes. I just missed all of them. I'd go to what was called recitation classes, which are small and you do problem sets. And mostly I tried to teach myself. how to do problem sets, and I keep doing problem sets and problem sets. Last 5 terms, I had better than an A average. They gave A pluses at Cornell. And I had the best grades in the class, and that those last 5 terms, but it was really, by not going to a lot of those lecture classes,
Yeah.
which I almost feel I certainly don't advise that my students to cut them all, but I just didn't get anything out of them, and I would just fall asleep.
Well, I'm curious. Yeah, I was going to go there. What are your thoughts now that you're on the other side of the coin, so to speak, and you've got students and you have classes for those? Because again, this came up even when I was in college, of the idea of like the different learning styles of different people. When you have a kinetic learner, an auditory learner, a visual learner, and just regardless of even the different, what do you call it, neurodivergencies, but like even if you're talking about just learning styles, sometimes a lecture is the worst way. I was the same way. I could not sit through a lecture. I did similarly. I did not go to class unless I was required to by an attendance grade. But I taught myself, and I was able to, and I loved teaching myself. So it was still a great structure to force me to spend 4 years learning. But going to class was never a big priority of mine. Not because I got decent grades. It wasn't because I was flaking out on school. It was because that wasn't the way I learned. So I'm curious, what are your thoughts on that these days, now that seeing that's where you came from, but now you work at one of the most prestigious colleges? What is the thought there?
Well, I think there's 2 parts to what you're saying, and I think all the things you're saying are on target. So first, me as a teacher, when I give lectures, lectures to a class that I do, I really try to keep the students engaged. I ask a lot of questions. And I also do things like try to tell stories and things like that, and I try to make it relevant.
Yeah.
So I sort of have learned 2 things as a teacher, to try, and I expect we'll get into this more when I go over my graduate school work, where I helped start the school for kids. But I think that what I'd learned as a teacher is 2 things that are very important, and sadly, which are not done very much on any of these things in math and science. One is to make things more fun, like sometimes to play games or to tell stories. And 2 is to make it relevant.
Mm-hmm.
Like I think so many kids, they don't, at any level, they don't know. And I certainly, I'd be learning all this stuff, about things like thermodynamics, which I would later teach in college. But it seemed so irrelevant. It's like steam tables of the 1700s and 1800s. And so what I tried to do was come up with examples that I thought would get the students engaged because they're relevant. Now, that doesn't really fully answer your question, because, how do you deal with different student types? And I think you sort of still recognize that what you said, that's the case, and you do the best you can.
Mm-hmm.
And sometimes I try to encourage students to get tutors. When my kids were growing up, we got them tutors sometimes, because I always say they got my genes for the ADD. They didn't get my wife's. But I think that so I think, and to always ask for help, and to go to the recitations, particularly if it's in a thing like engineering or science, because the teaching assistants can help you a lot.
Yeah, that was one of my favorite things to go to when I really needed to catch up, was those small breakouts where you'd work through problems.
Yeah.
Great.
Exactly.
So you get through, you figure it out, you need to learn on your own accord, and then you decide after an interesting experience in college just to keep going.
Well, yes, and no. So I did apply for jobs when I was in college, and I got some jobs running chemical plants. But I thought, why would I be a disaster at that? So I didn't really know what I wanted to do, so I applied to graduate school. I thought that would be a good thing, so I did. I applied to graduate school, and this time,
what do you want to focus on in graduate school? Like, were you doubling down on some aspect that you had really grown passionate about, or?
I really wasn't. In fact, one of the reasons so here in graduate school, I got into every place that I applied to. That wasn't the case for undergraduate, but the thing I liked best about MIT, I think, which I ended up going to graduate school in, is theirs was very diverse. There were like 8 areas of chemical engineering. And I thought, this is great, since I have no idea what I want to do. Several of those sounded like they might be more interesting than others, and that would not force me to, that would enable me to postpone, what I was going to do.
Yeah.
or what I was going to think about.
And so through that time, what did you end up focusing on? Like, when did you end up figuring out what you wanted to narrow down into?
Yeah, well, I don't know that I fully did, but I always liked medical stuff,
Uh-huh.
and but only like 2 out of 30 people were doing anything even close to that. And one of the professors was doing enzyme things.
Mhm.
And I thought, well, that sounded better than anything else. So I ended up doing this thesis on enzymes.
Uh-huh. Got it. And where did that come from? Where did the medical side come from? Just fascination with humans, or?
I think it came from, in a way, wanting to do some good for people. I didn't really know, and I hadn't taken any. Cornell was tough. I mean, they it was really, in terms of scheduling, they had just converted a 5-year program to 4 years, so you couldn't really, take biology courses or a lot of things. But I mean, it's a very good program, but it was tough that way. So I thought, gee, that would be interesting, and I'd kind of like to maybe help on medical stuff.
Yeah.
Or this was more biology than medicine, but I
Yeah.
thought that might be interesting.
But it opened the door. And so you end up completing that thesis and getting through grad school. Like, what did that open up for you? Like, as you're going through that, were you starting to think about what your career path could look like, or was it really just heads down, focus on this study?
Yeah, well, it wasn't heads down focus on the study. I did the thesis stuff, but I wasn't really very excited about it.
Okay.
One of the things I did when I was I learned a lot, but I decided as I was doing it, it bothered me. I didn't think the particular work I was doing was important. I didn't see why it would necessarily change anything. I was
Yeah.
naive, and of course I ended up being right. I don't think it did change anything, but but that being said, I also got involved. I really loved teaching. When I was a graduate student, I'm sorry, when I was an undergrad at Cornell, my senior year, I was a teaching assistant, and I really enjoyed working with the students. So when I came to MIT, I started doing some tutoring and for poor kids in the Boston area, and then I guess people heard I was pretty good at it, so some people were starting this school called the Group School for poor kids and people that maybe had dropped out or and so forth. So they asked would I help on that and actually get involved in starting their math department.
Uh-huh.
And so I did. I got very involved in this school called the Group School, and I developed like new math programs, chemistry program, and so forth. And the school, Cambridge in the 70s, maybe still was very very liberal place, and what they want, and yet it had a huge high dropout rate for high school, 35%. So anyhow, but their policy in the school, and the school students, dictated a lot of the rules. It was a very interesting school. It did great for many many years. But anyhow, so what I did is I so their rule was that you didn't have to take math, you didn't have to take science. So the first year when I did it, I think 5 out of 37 people took math. Second year, 45 out of 50,
Wow.
and so they took it because of what I said. You want people to do things because they like it, and I got involved in stuff like that. So anyhow, that was so I spent a lot of my time in high
So
school.
real quick, I don't want to glaze over that. So you went from 20% of students, not even taking it, to 90% in a year. Was
Yeah.
it just rumors flying that you were a great teacher? Like, what was it that all of a sudden everybody wanted to take your class?
Good question. I think that I don't know that I was a great teacher, but I think I did what I was telling you before. I think I made it fun, at least a lot of and I think that I made it more relevant. And I think maybe I like to think that they knew I cared,
Yeah.
about them. And I think that it's interesting. I'm still in touch with some of those students today. But and even some of their kids. So so it was things like that.
Awesome. Got it. You were saying.
Yeah. So I did that. So going to your question, but I kept doing my chemical, doing my research and completing that. And then when I was getting done my last year, well, everybody, this was now 1973, 1974, everybody in my class, not everybody, but most everybody went to work for oil companies.
Yeah.
Because they had tons of money. There was this gas shortage.
Yep.
Lines were getting gas in 1973 were like 2 hours in Boston, with your car. So they came to MIT and they offered me jobs, and I got to see the country for the first time in my life. I'd never been west of Buffalo or east of Boston before. Now I'd go to interviews in Texas and California, in Tennessee, and everything. And I got a lot of job offers. I got about 20 job offers, and I decided that even though when I was at these places, that people were nice, and I thought, that I could possibly see myself doing it. But then I'd fly back to Boston and I'd think, gee, some of these people said, gee, if you could increase the yield of this chemical by 0.1%, it'd be worth billions of dollars. And I just thought to myself, I don't want to spend my life doing that.
Yeah.
So I didn't. And then I thought, well, so one day so it made me think, what did I want to do? And actually, to the point that we were just making, one day I saw an ad to be a assistant professor at City College of New York to develop chemistry curriculum.
Mhm.
I thought, gee, that's what I want to do, because I was good at that so I wrote them a letter applying for a job, but they didn't write me back. But I liked that idea, so I'd write to a lot of other places, and about 40 of them. They didn't write me back either. And but that at least fixated my mind that I
Yeah.
wanted to do something to help people. So I thought another way to help people is medicine. So I started applying to a lot of hospitals and medical schools, and and eventually I got this job working at Children's Hospital.
So, so you come out of engineering again. You've worked with enzymes. You're doing some teaching in academics, engineering, and then you decide I want to help people. What did you get at Children's Hospital? Like, what job did they have for you that they were like, oh, this makes sense, like with no
Yeah,
actual medical background?
right. So what happened is I applied to a lot of hospitals and
Yeah.
medical schools, and nobody wrote me back there either. But one of the people in my lab mentioned that there was a surgeon named Judah Folkman,
Mhm.
and he said he hired like unusual people, but
Huh.
not meaning that. But anyhow, and so I wrote him, and he was nice enough to offer me a job. And he had this idea that was kind of was revolutionary at the time, um, that if you could stop blood vessels from growing, maybe you could stop cancer. And he said that the way the blood vessels grew were because of chemical signals. I
Mhm.
thought when I went over there that was an incredible idea, because it seemed to me that maybe that could be a whole new way of thinking about treating cancer. Um, and I liked him. He was a visionary guy, charismatic. Um, so I thought I would like to do it. Didn't pay anything like the oil companies,
Yeah.
but I thought this is a way I could maybe do something good for the world.
Yeah. So since you said it, I got to ask: has there ever been a point in your life where you're like, oh, I should have taken the oil company job and made more money versus going down this path? Like, have you? I shouldn't say a
Well,
point.
by the way, the answer to that question is I probably made a lot more money by not taking it.
Right. No, exactly.
But
So, but chasing your
but
passion.
it was never my goal. I mean,
Yeah.
it was never my goal to I wanted to do something worthwhile. So no, in fact, Dr. Folkman, he had a good sense of humor. I mean, we'll get to this, I'm sure, when you ask me other questions. But because one of the things I've done is make drugs last a long time sometimes, or target them to certain places. But anyhow, he used to say, when somebody asked about me, he said, "Well, if Bob went to the oil industry, he said you get your gas tank filled up once a year."
Yeah.
In 1974. But anyhow, I didn't, and I have no regrets.
Yeah. And so you jump in with him. Were you guys able to figure out this chemical treatment for cancer?
Well, we did, yeah. I mean, I suppose the answer is yes or no. We came up with the first steps. We developed techniques where you could study it for the first time.
Mhm.
One of those things was developing little tiny drug delivery particles, nanoparticles or microparticles, that could deliver molecules of any size, including nucleic acids like RNA or DNA or proteins or anything really. And we also developed some assays, and we published the very first paper that was showing that there were diffusible materials, that substances that could stop blood vessels from growing, and prove that in animals, and in a paper in Science, the journal Science, in
Yep.
1976.
Yeah. Which one of the
So,
most.
by the way, to that answer, to that question, it took, I mean, so the way science works
Yeah.
is, especially medical science, doesn't happen very quickly. So this, I suppose, it's a I like to think that that's kind of a milestone paper because it changed people's thinking. It
Mhm.
still took 28 years from that paper and literally billions of dollars by companies like Genentech before the first blood vessel inhibitor would get approved by FDA. But
Wow.
that drug was Avastin. That's been one of the biggest successes in the history of biotech. It's widely used for treating cancer, and
Yeah.
and there are many, many others too that are now approved for treating cancer. And actually, those molecules also can be used, different ones, for treating diseases of blindness in the back of the eye, like macular
Makes sense.
degeneration and
Yep.
diabetic retinopathy. But it took many, many years. I mean, just as an example, last year, 5 of these were approved by FDA,
So
and that's
28 years from when you guys came up with a thesis that could save, I mean, I don't know how many people, hundreds of millions of people over the course of those 30 years, probably. And
yeah.
what is, I mean, without any assumptions on my end, like why 28 years before you can get something approved like that? What is that? I guess better than why, because I don't need to go through the process. Do you think that that's the right process? Do you think that that makes sense as someone that understands the repercussions of, not going through the proper
Yeah.
testing channels? But 28 years is a long time.
It is. I think it's really complex. I mean, it's a great question, and there's not a simple answer.
Yeah.
One of the tenets of medicine, and I'm not a doctor, is the idea of first do no harm.
Mhm.
So safety is a big issue.
Yeah.
One of the huge misconceptions, I think, of politicians in our country is not realizing how incredibly expensive it is
Mhm.
to do medical research.
Yeah.
So because of the law and because of federal regulations and the idea of first doing no harm and all the clinical trials and all the manufacturing and everything else, it takes billions of dollars. This is not my
Right.
numbers, but so it takes a long time. It takes a lot of money, and the money is not necessarily easy to raise. People can point to the successes and
Yeah.
say, "Well, sure, it shouldn't charge so much," but if you don't, but then you're never going to have the money to do the research.
Yeah.
So I don't know the answer to that. It's always a complex thing. I wish it didn't take that long, but I also would never want to see harm done either.
Right. Yep, that makes sense. Was there any specific reasons why it took that long here? Like, again, 28 years seems like a lot longer than I'm even used to hearing for some of these drugs.
Yeah. Well, I think in general, from a discovery to clinical use, probably will take at least 20. I
Okay.
mean, from my experience, maybe
Yeah.
more. Uh, but that being said, yeah, people still were skeptical
Yeah.
of that this could necessarily work. There was a lot of skepticism when we first did this, and I think our paper changed that. It took champions at companies like Genentech, like there was a guy, Napoleon Ferrara. He believed in in this thesis and did really great work on that, and he kept pushing Genentech to do it. And Genentech, of course, was the first company to do it. After that, then lots of others would do it.
Yeah.
And so I think that, but it just does take a very long time, especially when something's sort of a new concept.
Yeah.
Whenever there's a new concept, so I guess there's two things. One, there's a lot of skepticism in the scientific medical community, the press, everything. And two, even if there isn't, it's incredibly expensive.
Yeah. Got it. And so you get this paper published in one of the most prestigious journals, and you know, put this together. Did that change your career right away? Was that a big turning point for you, or was it kind of okay? Great, we got this published. We get some, peer-reviewed journal, and now we're back to work.
Yeah, I don't think it changed it tremendously, but it did give me, I guess, confidence that I
Yeah.
could do this kind of stuff. And it did give me a feeling that I could see myself doing more of it, and
Yeah.
I really liked that, but I didn't, so I don't know if it was a turning point, but it was a good positive thing.
And so, what did that lead into? Like, once you had that, did you just continue to focus on this type of therapy, or did you start leaning into other things too? Now that you had put it out in the world.
Yeah, well, I got other ideas. Like I also the drug delivery part, the
Yeah.
nanoparticles and the microparticles. I
Right.
I was working on that, and then also what happened was so I worked at Children's Hospital as what I call a research associate postdoc for 3 years, and then I started applying for faculty positions. I like being at Children's Hospital, but a
Yeah.
lot of my friends said being a postdoc isn't going to lead you anywhere. And now I was getting ideas about how, by being there, about how you could combine medical stuff with engineering. And
Right.
I thought, gee, maybe being a professor could be an okay idea. So actually, I applied. I'm a chemical engineer. I applied to a lot of chemical engineering departments. None of them would hire me at that time. The idea of doing biomedical research that was highly experimental
Yeah.
as opposed to theoretical, that was really looked down upon. So I didn't get any jobs there. I ended up in a nutrition department.
Huh.
But when I was there, I I now I had the ideas of a number of ideas. One was doing more on that angiogenesis work, the
Yeah.
blood vessel work, but I had a lot of ideas on drug delivery. In fact, a lot of people told me that that never made any sense either. The fact that we could deliver these large molecules. So I started with my students trying to understand how it worked better, and I got other ideas on how to make on how I could change, create new materials. And later on, I got ideas with one of my friends about how we could make new tissues and organs, and on and on.
On and on. Typical day in the
Well,
life.
that was pretty close to 50 years.
Yeah, no, I know. And so again, the path here is what's remarkable is like you went from, yeah, I guess I'll go to engineering school because again, the train conductor sort of joke, but like to like basically pioneering biomedical engineering. Is that fair to say? Not trying to ask for a conceited, but like there wasn't really
Yeah.
biomedical engineering before you started getting into this, correct?
Well, there was,
Okay,
but I think I'd like to think maybe I made it very different than it was. I mean,
sure.
I think there was biomedical engineering to an extent. I
Yeah,
mean, now, not just because of me, because of a lot of people, it's a lot more.
yeah.
But I think that, I hope that we changed it some. I mean, because of maybe some of the people I trained, and maybe some of the things I did. I think we made it much more molecular, much more experimental than it was before.
And you were saying in terms of the path, you went from nano delivery and the uh, blood vessel work that you were doing to for further delivery to then tissue creation. Like,
Well, the other thing that
yeah,
we did, I mean, I kept up, we continue to do to this day things with nanoparticles and
yeah,
microparticles and delivery and other kinds of delivery systems. But in the early 80s, Jay Vacanti, he was one of the people I knew from the hospital. He came to see me about, he was doing liver transplants, and he and I started talking. Maybe there's a better way to do that someday. Maybe we could make tissues and organs from scratch.
yeah.
So we started combining materials and cells, and doing that. And so that's another area that I spend a lot of time on, where I spent a lot of time on over the last 40 plus years.
And where did you end up coming out with that? Were you able to grow the organs into the lab and put them into people successfully and go as it worked out?
Well, to an extent, it's still got a ways to go. It's
Yeah,
become a pretty big field.
right.
Now, I mean, and we did more, Jay and I and our students did more basic work. I put it into two or three pots. One is, like I say, we did the basic work. That's what you do in academia.
Yeah,
I have been involved both in the drug delivery and in the tissue engineering work in terms of start helping start different companies with my students.
uh,
But what I'd say is, more broadly, now you can make artificial skin for burn victims, and there's a lot of others things like making new blood vessels for heart disease, or that's in clinical trials, and there's a number of others that are in clinical trials.
uh,
But and so that would be one pot. Totally making new tissues and organs from scratch, and
yeah,
and there's a whole bunch that we've worked on and continue to work on, and a lot of our students do. Second pot is what I'd say organs or tissues on a chip. That could someday, because you could recreate these. We've
yeah.
created hearts on a chip. We're working on a brain on a chip. We've got a gastrointestinal tract on a chip. But the beauty of those things is that that could do two things. One, it could someday, and I believe already, start to minimize animal testing and human testing. It could accelerate
Oh
things. To
yeah,
your point about the 28 years someday. And secondly, um, is you could do what's called high throughput. You could test things much more rapidly because you can do it what I call in vitro, or test tubes, rather than
yeah,
animals or people. And then the third part, I'd say, which I certainly didn't have the idea at the time, but which a number of my students and other people have done, is that you could use this approach to make entirely new things. So, two of my students have companies to make meat, and lots of other
yeah.
people are making tissue engineered meat. another company, Modern Meadow, they're making leather, I think, and they're making other kind. So there's all kinds of things that you can use the approaches the concepts that we came up with to do, and many people have taken it, in all types of different directions, which is great.
Yeah, no, that's awesome. And did you getting into this? Again, you're someone that wanted the information now. You didn't like to sit through lectures. Did you think that some of these innovations you would create in the 70s and 80s would take 20, 30, 40 years to come around as you were doing them? Did you expect that timeline, or was that how did that?
I'm actually sometimes I look back and I'm shocked that I accomplished anything at all. I didn't have the self confidence that when I was in college or starting to do research, that anything I did would really make an impact. But as I started doing it, it really meant something to me to make an impact. So that's why I've gotten involved in starting companies and other kinds of things, because I wanted to see all these things happen, and why I consult. And I feel like if I work with, not only do academic stuff but company stuff, help the government too, I can hopefully make things have an impact and not just be a scientific paper.
Yeah, and you were mentioning earlier that it takes, and I'm aware of this too, like billions of dollars to make one of these things happen. Like it's like people don't even, they very much underestimate how much it takes to come out with a drug or do these kind of things. And a lot of times it's a binary outcome because you can get all the way down the path, spend the billions of dollars, and nothing happens. Like it just doesn't get approved. It doesn't end up, doing what you wished it did. So when you were going down the path of creating these new innovations, how did you get that support? Like how did you get these universities to fund it or these grants or like, how were you able to, again, get the support for all the work that you've done?
Well, it's really changed over the years. I started out trying to write, Dr. Folkman had gotten, research money to support me for, when I was a postdoc. But later on, I would write grants, like grants to the NIH. And actually, I did terrible in the beginning. My first 9 were rejected, and I had a very tough time. But then I sort of learned maybe some rules about how you get these grants more, which is, you have to have more preliminary results and things like that. And so I learned how to write the grants better, and then I finally started getting some. And then I also wrote patents, and sometimes I'd use those patents to get industrial support.
Yeah.
That would feed back even into MIT.
Yeah.
And then I wrote to foundations. One of the things I learned in the group school, helping there, because I not only did teaching, I did fundraising, is that there's 2 things. One, it doesn't matter how many times you get turned down, it matters how many times you get something. And 2, to look sometimes in unusual places. So I would sometimes not do the standard kinds of places. I'd find foundations or almost anything that I could do to get it. Even when I first started, MIT would give you $350 research support for every undergraduate you took. So I took a lot of undergraduates, but they had a good time. So at any rate, it was, but it was a struggle. So that was probably for the first quite a number of years. But then as we maybe, but then we published stuff, and
Mhm.
in good journals, and I got more credibility. So I did 2 things. One, I do more things in our laboratory, but 2, I would try to help get these companies started,
Yeah.
and venture capitalists would come to see me, and they thought some of the things I did, maybe could be useful, and
Mhm.
we started these companies, and some of them did really well and made those investors a lot of money. So they would keep coming. Different ones would keep coming to me and say, "Well, would we might like to work with you on this or that." And then in the meantime, some of my students would be also not only go into academia or companies, some of them would become investors or venture capitalists. And so you sort of develop this, like, again, it's over 40, 50 years.
Yeah.
So then, but then I'd say probably by the 2000s, I've been doing this for a while, then I'd start getting approached by foundations like Juvenile, which shocked me. But all of a sudden, people came to see me and say, "Well, can you help us with this? Can you help us with that?" And so the Juvenile Diabetes Foundation came to ask about possible things that I might be able to solve in diabetes. Bill Gates and his foundation came to see me. Could we help create things that would help the developing world? And so, but so it was an evolving process. Part of it, I think, just takes time and credibility. In the beginning, I had zero credibility and probably very little confidence. As the years progressed, we published a lot of papers and in good journals, and we have a lot of patents. And then some of the companies we've started have done well. So the credibility kept changing over time.
Makes sense. And when did you end up back at MIT? What year did you end up back there?
1977.
Oh, okay. So it was very, you've been there like most of your career, you went back to MIT.
Yeah, I,
Yeah.
I guess the last 46 years I've been in the faculty.
Yeah. I'd like to think that's probably most of your career. That's in this
I
case.
think so. Yeah.
Do you think that, I mean, I assume that was also helped play a part in terms of the prestige and the respect that MIT
Yeah,
garners as well?
MIT has a lot of, yeah, it not only that, it also has great students and
Yeah.
great professors. And so, yeah.
And so, a couple more questions for you. Number one, what's next? What's exciting coming down? What are you excited about? With all these innovations you made, what is like the thing that's really keeping you motivated right now?
Yeah. Well, I think there's several things. I always think there's three things that I like to do. One is more basic research, more, fundamental ideas. Two is translating those ideas to the point where they'll help people. And three, training the best people in the world.
Yep.
So let me go over each of those a little bit. I'd say some of the newer things we're doing that I'm excited about from a basic standpoint are things we're doing with the Gates Foundation. We that they've been a big supporter, and we're developing medicines that, like, you could take a pill that might last for for rather than a day, might last for a month, and also give you much more steady blood levels, so you wouldn't get side effects.
Yeah.
We're developing vaccines that you might only need to take once. That we call them self-boosting vaccines.
Huh.
We're working on better ways of nutrition and to make preventing. People don't realize this, but lots of things, when they put them in, like take probiotics and they put them in yogurts and everything, they degrade. So we're working on that. We're working on new what I'll call band-aids, microneedle patches that could deliver drugs, and so things wouldn't hurt, and it might last a lot longer. And so a lot of those kinds of things. And then we're working in the lab. We have ideas on how you could someday deliver. I mean, one of the big areas that we've been involved in, which we didn't talk about, is things like messenger RNA delivery and genetic delivery. So, one of the companies I helped start was Moderna, and that's been. And I was very involved in Alnylam from the beginning. Also, I was on their founding scientific advisory board. So they're doing things like RNA, either knocking it down or gain a function. So we're working on delivery of RNA or any kind of molecule, large molecule, orally, rather than injectable, and so that's one set. And then when I mentioned tissue engineering, we're working on creating new tissues and organs, including like a brain on a chip, as an example. Which,
Yeah.
not because we're trying to do some space age thing, but that we're working with Liwei Sai at MIT and Alice Stanton, my postdoc, and the idea is, we could understand things about the brain much better if we can sort of recreate it.
Yeah, so when you say on
And
a chip, it means a computer model that you can then test against of the.
well, I more mean an in vitro system, like a
Okay,
system.
got it.
So you take 6 or 7 cell types, you figure out the right way to put them together, but it could mimic things like how do you deliver drugs through the blood-brain barrier. So
Yeah.
you could test things and maybe understand things. So that's one thing. Second thing, so that's like the first thing, the research we do.
Yeah.
The second thing is creating new companies that can take these things with my students and bring them out to the world. And the third thing is really just training great people. Like one of my students this year got a professorship at Harvard. Both women, actually, another at Stanford, and others at BU. I mean, so the training people and others have started companies, and so all those things, I want to continue doing that, and hopefully, we can, make biomedical engineering even more than it's been so far.
Yeah, it's a lever on your time. You're creating the people that can go create. And so, or helping, I should say. So
Yeah.
you get a lot more done at scale. Last question for you. For someone that wants to pursue their dreams, again, this might have not been something you dreamed about, but now it seems like something you have dreamed about for 45 years. What would you be your either one piece of advice you wish you got or you did get that helped you stick with it? Again, you talked about the 9 times you failed when you first tried to apply for grants. Like, what made you keep going? And like, what's some piece of advice you'd give to other people in that sense?
Yeah. Well, what I usually say to people, like when I give a commencement speech, I usually, one of my friends, Sherry Oberg, she heard one that I gave, and she said, "Well, what you just said, is you dream big and never give up." I mean, and I would say that that's what I believe in, I suppose, what I've tried to do. Why do I feel that way? Well, I was lucky that I worked with Judah Folkman, who I mentioned, and he was a lot like that. He never said those words, but he was a living example of somebody that dreamed a lot and didn't give up. And I shouldn't always say never give up, but I always say when I give a lecture, almost never give up. Certainly don't give up easily.
Yeah, absolutely. Well, Bob, this has been amazing. Thank you so much for coming on Hawk Talk.
Well, great, terrific questions. Thank you so much.
Of course.